Hello everyone, I am Monica Hira from Laval Convent School. Today the topic of my explanation is Structure of Atom, Class 9th, NCERT. In this explanation, I am going to explain about the discovery of electrons, protons and neutrons and the contributions of various scientists in the structure of atom. Discovery of protons. Protons were discovered by E. Goldstein in 1886. He observed the presence of positively charged particles in an atom by the experiment. He repeated the experiment of the discharge tube using perforated cathode. On applying a high voltage under low pressure, he observed a faint red glow on the walls behind the cathode. Since these rays originated from the anode, they were called anode rays. These are also called canal rays or positive rays. Thomson model of an atom. J.J. Thomson was the scientist who discovered electrons. He passed electricity at high voltage through a gas at very low pressure, taking in discharge tube. The glass tube is also connected to the vacuum pump to regulate the pressure of the gas inside the tube. In the discharge tube, on applying high voltage at low gaseous pressure, the negatively charged particles are emitted from the surface of cathode. These negatively charged particles constitute the cathode rays. When Thomson proposed his model, neutrons were not discovered. This model was similar to plum pudding. According to this model, an atom consists of positively charged sphere and electrons are embedded in that sphere. The positive and negative charge are equal in magnitude, hence the atom as a whole is electrically neutral. But there were certain drawbacks of Thomson model. It could not explain the results of alpha ray scattering experiment conducted by Rutherford experiment. He discovered the nucleus. Alpha rays are positively charged helium ions which have a mass of 4 units and 2 units of positive charge. Rutherford allowed a narrow beam of alpha particles from a radioactive source to strike on extremely thin sheet of gold. He selected a gold foil because he wanted as thin a layer as possible. Observations of Rutherford. Most of the alpha particles pass through this foil of gold without any deflection from their original path. Few of the alpha particles were deflected from their original path by small angles as they encountered the target. Very few alpha particles actually bounced back in the direction from which they came. Surprisingly, only out of every 12,000 particles appeared to rebound. There were certain conclusions made by Rutherford. On the basis of the observation in alpha particle scattering experiment, Rutherford concluded that atom consists of predominantly empty space because most of the alpha particle pass through the gold sheet without any deflection. Atom consists of a central nucleus containing positive charged particles because few of the alpha particles suffered deflection and even bounced back in the direction from which they came. The space occupied by the nucleus is very small as compared to the total volume of the atom because a minute fraction of the alpha particles underwent strong deflection of 180 degree. On the basis of this data, he stated that radius of the nucleus is about 10 to the power 5 times less than that of radius of an atom. Very few alpha particles bounced back on hitting gold foil. This shows that nucleus is very dense and hard. So practically whole of the atomic mass is concentrated in the nucleus. On the base of his alpha particle scattering experiment, Rutherford stated that there is a positively charged center in an atom which was termed as nucleus. Nearly all the mass of an atom resides in the nucleus. The electrons revolve around the nucleus in well-defined orbits like planets are revolving around the sun in solar system. The electrostatic attraction between nucleus and electrons keeps the electrons in the orbits. The size of the nucleus is very small relative to the size of the atom. Effects in the Rutherford model. According to classical electromagnetic theory, a moving charged particle such as an electron under the influence of attractive force loses energy continuously in the form of electromagnetic radiation. As a result of this electron should lose energy and therefore should move in even smaller orbit, ultimately falling into the nucleus. It has been calculated that an atom would collapse in 10 to the power minus 8 seconds, but the collapse does not occur. There is no explanation for this behavior. According to Rutherford, the electrons revolve around the nucleus in fixed orbits. However, Rutherford did not specify the number of orbits and the number of electrons in each orbit. Bohr's model of an atom. To overcome the drawbacks of the Rutherford's model and to seek the theoretical explanation of the existence and regularities of the spectral lines, Niels Bohr in 1913 proposed a modified model of the structure of the atom. Bohr made the following assumptions. Electrons revolve around the nucleus in circular orbits. Although a number of circular orbits are possible around the nucleus, but the electrons revolve only in certain permissible orbits and not in other orbits. These special orbits are also known as discrete orbits. The energies of permissible orbits are fixed and therefore these orbits are called stationary states or energy level or shell. Energy levels or shells are designated by English letters K, L, M, N, O, P, etc. The K orbit is nearest to the nucleus and therefore it is the first orbit. L is the second orbit, the third orbit is M, and so on. There is a limit to the maximum number of electrons which an energy level can hold. As long as the electron revolves in this discrete fixed energy level, it does not lose energy, so they do not fall into the nucleus and hence atom remains stable. Thus the energy of the electron remain constant in a fixed orbit. Electrons in different orbits have different energies. Energy is emitted or absorbed by an atom only when an electron moves from one orbit to another. When an electron jumps from a lower energy level to a higher energy level, it absorbs energy. Thus the electron becomes excited. Similarly, when an electron jumps to a lower level from a higher energy level, it emits energy. How are electrons distributed in different orbits or shells? The maximum number of electrons present in a shell is given by the formula 2n square, where n is the orbit number or energy level index 1, 2, 3 and so on. Hence, the maximum number of electrons in different shells are as follows. First orbit or K shell will have 2 electrons. Second orbit or L shell will have 8 electrons. Third orbit or M shell will have 18 electrons. And fourth orbit or N shell will have 32 electrons and so on. The maximum number of electrons that can be accumulated in the outermost orbit is 8. Electrons are not accumulated in a given shell unless the inner shells are filled, that is, the shells are filled in the stepwise manner. Electron has the symbol E. Its absolute charge is minus 1.6 into 10 to the power minus 19 coulomb. Relative charge is minus 1. Proton is symbolized by letter P. Its absolute charge is plus 1.6 into 10 to the power minus 19 coulomb and relative charge is plus 1. Neutron is symbolized by small n. Absolute charge is 0 and relative charge is also 0. J.J. Thomson, an English physicist, discovered electrons in the year 1897. Eugen Goldstein, a German, discovered positive particles in the year 1898. Ernest Rutherford, a New Zealand-born British, discovered protons in nucleus in the year 1911. James English discovered neutrons in the year 1932. Thank you for listening.